So, okay, everyone, welcome everyone. Good afternoon from Thailand, and thank you for joining us today. I am Antapon Vishadis, and I will be your moderator for this exciting and informative sessions. We are thrilled to have you with us for today's webinar on updates on immersion cooling and its impact on data center availability. So as technologies continue to evolve, we do need of data centers that support the world's digital infrastructures, one of the most groundbreaking innovations to address the growing energy demands and thermal challenges of data centers is immersion cooling, a solution that promises to improve efficiency, reliability, and sustainability. Today, we have the privilege of hearing from two industry experts who are at the forefront of this transformation. First, Mr. Asanka De Silva, General Manager from APAC at Submer, an organization pioneering at the development and implementation of immersion cooling technology in data center across the regions. And the second one, Mr. Mohamed Navi Said, Vice President at the Uptime Institute, an independent authority on data center performance and reliability. These two leaders will give us valuable insights into how immersion cooling is changing the way data center operates. It potential to boost data center availability and the broader impact on sustainability and operational efficiency. Before we dive into the discussion, I'd like to remind everyone that this session is interactive, and we encourage you to share your questions throughout the presentations. You can submit them using the Q&A functions on the chat box, and we will address them during the dedicated Q&A segment toward the end. Now, without further ado, I'd like to invite the first speaker, Mr. Asanga De Silva, to on the stage to speak out about his insight.
Thanks, Antapon, and then very good to meet everyone as well. Thanks for having me. Let me share my screen. Just give me a second. All right. So can you please confirm that you can see my screen?
Yes, we can see
Excellent.
your screen now.
Excellent. Thank you. Okay. So look, thanks for having me, and thanks for the introduction. And so I'm from Submer. I'm the GM for the APAC region, based out of Singapore. It's very interesting times in the data center cooling industry, because we are in a very interesting stage, because we can see the transition from air cooling to liquid cooling. And you know, exciting time. So when we speak about liquid cooling, we have to first look at as to why data centers need to design for liquid cooling for the future. Okay, so that's a critical question we get asked. Now, what I want to share with this slide is, if you look at all the roadmaps from the silicon manufacturers, it's showing the densities of the chips are going up, right? That's no secret. You're all aware of that. So if you look at you know, the projections from the Intels, the AMDs, and the NVIDIAs of the world, the chips density of especially the GPUs, right? The densities are predicted to go up beyond the 2000 watt level within the next 3 years. And even if you look at the rack densities, it's sort of moving beyond that 500 kilowatt sort of mark, in the next 3 years. So these are quite significant changes which we will be seeing in the industry, and this is why we are getting ready for this type of change, right? So even if you look at direct to the chip, the feedback we are getting is there are limitations sort of beyond 175 kilowatts per rack level, right? So when it comes to liquid cooling, okay, there's two types, right? So direct to the chip, and then you have immersion cooling. So we believe that immersion offers the best total cost of ownership when you compare all the solutions available for the data center cooling options, and also the most sustainable solution out there for us for the data center. So now, so the question then is, with all these benefits, why is immersion not mainstream yet, right? So that's a question it'll come to your mind as well. So, but that's because there are a few key bottlenecks for immersion, right? So I'm planning to address some of those bottlenecks, the ones which are sort of blocking the adoption of immersion, as well as how can we overcome those challenges with education as well. Okay, so let's move on to the next slide. Okay, so when you design an immersion cooling solution, you always need to start from the compute, right? So what are you planning to immerse in that tank? What applications are you planning to run? What compute loads, workloads, and based on that, your server specification will be defined, right? So, so when it comes to immersion, this is what we call the ecosystem. So the ecosystem is crucial, right? So what are the main parts of the ecosystem? So the question we get asked is, okay, so we know for air cooling, it's a very established technology. We all know this. Direct to the chip, the server vendors are there. Everyone's providing the warranties. The system integrators are there. It's all set up. But for immersion, is the ecosystem ready today? This is a question we get asked regularly. So there are three parties when it comes to the immersion ecosystem: your silicon, your chip manufacturers, your server vendors, and the fluids, right? So for an immersion solution to work, it's crucial that we work with all these parties very closely, and that's an important piece. So at Submer, we take this very seriously, and this is where the whole validation of servers, chips, fluids in our tanks come into play. So for example, we are just opening up a lab in Taipei, in Taiwan, in May. One of the key roles of this lab would be to work very, very closely with the server OEMs to ensure that these equipment is validated in the tanks. Okay. Now, the ecosystem, when it comes to the ecosystem, another crucial piece, as I said, the servers. So let me share with you on where the server market sits today with the immersion world. Okay. So you can categorize into three parts. Okay. So you got some server vendors who manufacture servers which are ready for immersion today. And there are some OEMs who retrofit the servers. And then there's another, OEMs who manufacture immersion servers for specific projects. Okay. Now I was in Taiwan a few weeks ago, and I can confirm that in the next 4 to 6 months, this slide will look very different. There'll be new logos in, and also there'll be more logos under that immersion born category. So, so what does it mean by immersion born? Immersion born is you design your server from day one, the most optimal way for the fluid to run through your servers and absorb all the heat. And as a server manufacturer, you will be providing the warranty for the servers as well, right? So this is where the change is happening, and this will help the industry to slowly change more and for immersion to become mainstream as well. Okay, when you talk about the silicon manufacturers, now they are also planning immersion in their roadmaps. Okay, if you look at NVIDIA, there are many megawatt scale deployments today in immersion with NVIDIA systems backed up by the server manufacturers. Okay, and so it's not too long until guys like NVIDIA, comes to the party and have a more structured approach towards immersion as well. Okay, so I mean, in a nutshell, the supply chain for immersion is getting ready for scale today, right? Okay, so let me move on to the next slide, which is okay. So when it comes to today's topic is about the data center availability, right? Now, one of the most important things when it comes to immersion, and also one of the key barriers to the adoption of immersion, is the myths around operations and maintenance, right? If you speak to anyone on immersion, they will throw numerous facts or details about how difficult maintenance and operating immersion systems are. Okay, so the main reason behind this is the lack of exposure to the technology, because it's new, right? It's an emerging technology. So this is where our role comes in, where we try to educate the market to better understand on the ease of maintenance when it comes to immersion. So a common question I get asked is, does immersion needs specialized labor, for example? Okay, so let me put it this way. Training existing IT operation staff to work on immersion is not hard. Okay, so I'll give you an example. Today at Submer, we onboard new partners in different markets, and these partners don't come with the prior knowledge of immersion, because it's as I said, it's emerging technology. It's not like everyone has experience with the technology. So we have very robust processes in place to train them for install, commissioning, and maintain the systems, and also standard operating procedures to maintain these solutions. So I can confirm training staff or your tenants, your existing facility staff to maintain immersion is not difficult. Okay, and also if I look at the next point is when it comes to the whole product side of things and operations of the unit. So this, what I'm sharing now, is called the EXO, which was launched last year. And the EXO is a hyperscale grade smart pod. It can go up to 361 kilowatts in one tank. It's got the 5 nines, high availability ability, and also it's really designed with ease of maintenance in mind. Okay, so you look at this, the front of the tank, you can remove the front panels and put your rack PDUs in there, so your bus bars can directly connect to the rack PDUs. The rear of the tanks got like quick connect piping, so it's easy to connect the water in and out. And also one of the main features of the solution is you have something called an auto leveling feature. So for example, if you want to maintain your server, when you lift your server, as you can imagine, the fluid level will go down, right? With the auto leveling feature, you have a buffer tank, which will then pump some fluid back to the main tank to make it bring back to the right level for the fluid in the tank. And also, once you fix your fault of your server, when you want to immerse the server back into the tank, the fluid level will increase. Now with the buffer tank, the extra fluid will flow to the buffer tank, and it will normalize the right level of fluid. So these little things which hasn't been in the previous versions of tanks, but has been well thought of, just to make sure that when you deploy an immersion cooling solution at scale, it's easy to maintain, and it's easy to operate. Okay. And talking more about operations and maintenance, sorry, let me flag this out. So talking about high availability, right? So high availability is in terms of redundancy. So this solution here is called the twin tank solution. So it's crucial for data center operation, because if you look at, so this is a CDU. So this is your tank, and this is the CDU. And twin tank solution is you got two of those, right? So if one CDU fails, while the two tanks are running, the other CDU can take over the load of both tanks, right? So that's how we maintain high availability in immersion cooling. And you could replace the failed CDU while the two tanks are running. So you can remove, isolate the quick connect valves at the rear of the tank, remove the CDU, and then put the spare CDU in, reconnect the valves, and bring the second CDU online. So again, establish redundant operation, right? So this is a crucial feature for the data centers, and again, just helps to ensure redundancy is maintained across the data hall and across the whole data center. Okay. Okay, so a little bit more specific or more details on operations and maintenance. Coming back to my point, which I mentioned before on myths around maintenance. So a few facts. Okay, with immersion, as you probably know, the servers do not have fans. Okay, and also when you immerse the servers in liquid, you remove dust and you remove moisture from the equation. So what does this mean is you got these servers running in dielectric fluid without any moving parts and without dust and moisture. The longevity of the servers increase. So out of our experience, because we have about 400 megawatt of immersion cooling deployed on the ground today, the failure rate of servers is only about 1%. Okay, so what does this mean? This means when your failure rate of the servers reduces to that level, the interactions, with the servers is less. That means you have less requirement for maintenance to start with, right? So there's a couple of important things when it comes to maintenance and immersion cooling. There's less needs for operations, number one. Number two, how can we optimize the few operations needed to do on the system, right? So in order to do that, we've actually introduced something called an operations card. So now this, this is how it's going to look. It'll be released in about 3 to 5 months or so. It's a patented product for Submer. So you bring the operations card next to the tank, and you can, when you need to maintain or if there's a server failure, you connect the crane to the server, and then there's a battery. It's battery operated, so you just lift the server using the crane, a mobile crane, and then you place it on the operations card, do whatever the maintenance you need to do, and crane it back into the tank, right? And also, one of the crucial things when it comes to the maintenance of immersion cooling is to check the chemistry of the fluid. Okay, so in the past, what we had to do was to get the customers to send a fluid sample to our labs to validate the chemistry. Now, what we are doing now is with immersion to grow in scale, you can't be doing that because it's too much on the logistics side of things. So this is where the operations cart will have the capability for you, for your facilities staff, to take a fluid sample and test it yourself. It's like a litmus test. So like a traffic light method where if the fluid is functioning fine, it'll give you the green light. If there are some corrections needed, it'll give you, amber. And if there are some serious issues which we need to address urgently, it'll go red, right? So we are trying to make maintenance and operations as simple as possible. So immersion will be accepted and can be, grow in scale. Lastly, is about the fluid. Okay, so a lot of people ask me, okay, how safe is the fluid? Because there's lots of different fluids in the market. So if you take two-phase technology, the fluids used are different. Some of them are toxic, and some of them just evaporate, forever chemicals, all that sort of stuff. So single-phase immersion, the fluid used is safe for human use. It's for example, the fluid we use, lifespan 15 years. It's transparent. There's no smell, and also most importantly, it's biodegradable. So all those sustainability benefits, does exist. We have even obtained a food grade certificate for the fluid as well, just so that we can confirm that it's safe for human use, right? So look, that wraps up my slide presentation, and just want to wrap up by saying that we are working very, very closely with the ecosystem, which is the chip manufacturers, the fluid manufacturers, and the server OEMs, to ensure that all these components which are needed for immersion cooling are tested, validated, and performance is confirmed, and then we can sort of help the users to use immersion and to grow in scale. Okay. On that note, thank you very much. And just at the end of the presentation, feel free to ask any questions. Thank you.
So thank you for Mr. Sewa. And we're gonna move on to Mr. Mohammed Nawi Said, our Vice President for the Uptime Institute. Then we're gonna answer the questions after the end of the of the section. So yeah, and so it's time for you to sharing your insight, Mr. Mohammed.
Hi everyone, my name is Mohammed Naveed Said, and good evening, good afternoon, and good morning if somebody is in the Western Hemisphere where I am at the moment. So it's quite early in the morning of my time, and I will be sharing my screen in a while with you. I think my system is asking me to restart, so I think I need to disconnect and connect back in a minute. So just give me a minute. All right, all set. I believe you are able to see my screen. Can anybody note, or just to confirm that you can see my screen?
Yeah, it's uploading now, and I think it'll pop up in a few seconds. Yeah, it's all good now. It's all set.
All right, perfect. A little bit of my introduction. I've been into the data center industry and mission critical facilities from last 20 years. I am Vice President, Global Engineering and Delivery at Uptime Institute, and work very closely with the clients in delivering project certifications, assessments for design facilities, as well as the operations, and also part of the team that is overseeing the education and training at Uptime Institute. Uptime Institute has a huge training arm that helps to upskill data center professionals throughout the globe. It's no secret at the moment that the liquid cooling and direct liquid cooling adoption is growing. And these are the results from our intelligence survey 2024 that shows that a total of 22% respondents report that their organization is making some use of DLC in their facilities. And 3 out of 5 says that they are not currently using DLC, but they will consider doing so in the future. So, which itself is a massive adoption indication in the industry. And nearly half of the DLC users report that less than 10% of their organization is using it now, and only for few servers. The adoption is there, but the adoption is not at the mass scale. But as we are going with the higher TDP GPUs, CPUs, and LPUs, this adoption is going to grow in future, and these are the indications where everybody is talking about. NVIDIA's roadmap shows that they are going to have racks up to 250 kilowatts per rack density. On their roadmap, they are already touching at 130 kilowatts for now, but they will be moving over and above it in some time. And that is actually the challenge. That's the actual requirement that is pushing the adoption of liquid cooling. NVIDIA is not the only one. Other manufacturers are also heading the same direction. If we look at today, and this is Uptime Institute's Global Data Center Survey from 2023, that shows that 56% of the facility is still using perimeter cooling with the cryo units or fan wall units, but it's some kind of perimeter cooling. 18% are using for close couple cooling. That includes in-rack cooling, in-row or rear door heat exchangers, and 11% are using direct cooling, and that includes all kind of direct-to-chip, DLC, and immersion cooling. And if we break down further, the 11%, the water-cooled cold plates are 6.8%. Full immersion is about, single-phase full immersion is about 3.3%. Dielectric cold plates are 1.4%. Full immersion two-phase is less than 1%. And partial immersion systems are 0.3%. Now, they are all different type of cooling technologies, though are employed in data centers by different users to test the efficiency of cooling systems and to test the heat rejection capabilities. The IT landscape is changing very quickly. The manufacturers are copying up, and they're coming up with a number of servers that can support both direct to chip cooling as well as immersion cooling. And if we look at immersion cooling, on the left side we have immersion cooling servers. So Gigabyte and Dell has immersion cooling servers, and on the right side we have cold plate and on-chip liquid cooling, and Cerebras and NVIDIA DGX H100, they are supporting direct-to-chip cooling. So it depends upon which kind of IT hardware that you're going to use. You have to design your data center cooling infrastructure accordingly, and not only cooling power as well, but I think we are going to be focusing more on cooling in this session as it is related to new cooling technologies in data centers. So that's really important to know for data center professional or who are on this call, who are designing for somebody else, or they're designing their in-house data centers, new racks, or new IT refresh. They need to understand very well what kind of IT refresh is going to come in there. In the past, our conventional data centers used air cooling systems, so it doesn't matter which kind of equipment is going to come in. Air is air, and as long as you can deliver air to a specific rack, you can, to up a certain density, you can support the cooling on those racks. Although there's a lot of challenges, and the people on this call who have been operating those facilities and upgrading IT refresh on those one, they also see a significant challenge in delivering cold air all the way to the specific racks, especially the higher density racks in that context, around 20-25 kilowatts per rack. But in this case, it is more specific and more particular. So designing a facility, knowing the racks, how to deliver the liquid all the way, and how to remove the heat from each kind of server is very important, because without the right design, it will be not possible to place any server in any rack or in any immersion wet. Then there are further types of liquid cooling in each category. Immersion cooling has two categories. Broadly speaking, is single phase and two phase, and even within single phase there are multiple type of single phase liquids, and in two phase there are multiple type of two phase liquids. So then you have to look further into those, which kind of technology you are adopting, and what is the material compatibility for those liquids with the equipment that you're purchasing or you will be buying, and what's the roadmap of your organization to do that. So these are the things which has never been a problem in the past, but these are the things that need to be handled, and these are the challenges that need to be solved by the data center professionals in the new era. On the cold plate side, it's on-chip liquid cooling. So there is 4 categories. Again, single phase liquid, multiple type of single phase liquids are available out there in the market. Two phase liquid, dielectric fluids, and clean water, deionized water, water glycol mix, and the sidecar arrangements are out there. So again, what kind of infrastructure you are going to put there, your cooling has to be compatible with that. So liquid cooling landscapes looks like 3 major categories of fluid being used: water, two-phase dielectric fluid, and single-phase dielectric fluid. Water and deionized water is and single-phase and two-phase. They're all used in cold plates. Water and deionized water is not used for the full immersion cooling. For full immersion cooling, it's either single phase or two phase dielectric fluids, and chases or partial immersion, it's also either two phase or single phase dielectric. And I think for chases and partial electric, it's mostly single phase dielectric because it's impossible to seal that one. So it's based on the vapors cannot be contained. So it's single phase dielectric fluid. So if we look at water, it's a water glycol mix or a deionized water. For two phase, these are engineered fluids, and there are some concerns around the safety of these fluids because they have forever chemicals, and this is something need to be looked after when you are trying to adopt a two-phase dielectric fluid. Single phase are usually mineral based or bio oil, and they can be engineered as well, but they are considered more safer than two-phase dielectric fluids in adaptation. There's certain advantage and disadvantage to, or not disadvantage, but I would say that there's certain advantages of using two-phase dielectric fluid and single-phase dielectric fluid. So heat absorption efficiency of two-phase dielectric fluid is considered to be higher than the single-phase dielectric fluid. However, the two-phase dielectric fluid requires a vapor-tight system, so the vapor can condense back into the tank, while single-phase dielectric fluid doesn't require that. You definitely create a ceiling for dust and other equipment to be protected, but it doesn't require to be vapor-tight. In immersion cooling, a two-phase dielectric fluid claims that they don't require any pumping, but there's some pumping costs associated with the single-phase dielectric fluid. If the two-phase dielectric fluid is used for cold plate, then pumping costs are there. So it depends. It varies with what kind of infrastructure being used for these kind of dielectric fluids. The fluid cost is much higher for two-phase dielectric compared to single-phase dielectric fluid, and the IT compatibility of single-phase dielectric fluid is proven to be more and wider than two-phase dielectric fluid. So a bit of comparison or benefits of each type of dielectric fluids. Now, since we understand that what kind of liquid cooling technologies are out there, and there can be more variations to that in future, I think it comes to the human capital that how these liquid cooling technology can be adopted successfully. And if they cannot be adopted successfully, it will be hard to capitalize all the advantage that the industry can get out of these technologies. So AI training clusters embrace liquid cooling. Mainstream IT is changing, but more slowly because the TDP of the CPU is not growing as fast as the TDP of GPUs. Cold plates and immersion designs are each evolving to prepare for tomorrow's extreme density AI hardware. Co-location providers prioritize flexible infrastructure design to minimize cost, uncertainty. So if it's an enterprise data center, it's much easier that you can go to the IT team. I will not say it's very easy, but it's still possible to get some insights of what kind of hardware is going to land into your data hall. But for co-location providers, they don't know who will be the tenant unless they're building for a specific tenant, and what kind of IT gear is going to be there. So it's even more hard. It's more difficult and more challenging for them to understand, and their design need to be more flexible that can adopt, they can comprehend, and they can install hardware from the tenants that can be compatible with their upstream infrastructure for chillers and power densities and everything. So that is something I think industry at the moment is contemplating how to resolve it. And as we will go into more and more deployments, we as overall as industry will find the ways to make it more standardized. There are some other design considerations that need to be considered by the data center professionals. And if you are on the design side or operation side and managing the capacity of your data center, so you need to be mindful of these requirements. And some of these are listed on this slide. Space requirement is one of them. So liquid cooling system may require additional space for cooling distribution units, CDUs, heat exchangers, piping, pumps, and tanks. Depends upon the type of liquid cooling, cold plate, or immersion. Now again, depends upon which kind, how do you want to split your white space and the gray space or the cooling gallery. Where do you want to put your CDUs and heat exchangers? So you might like to have your CDUs and heat exchangers, and I'm talking about the end of row CDUs and heat exchangers, probably in the mechanical gallery where we used to have our fan wall units and CRA units traditionally in a traditional data centers. But still the piping will be running all the way to each and every rack, which is a kind of new thing and has not been widely adopted except somebody is operating a facility with the rear door heat exchanger and in-row cooling units. So I think this is a kind of a new new requirement that has to be addressed by the data center professionals. Now, this space is not only in the white space size, the space inside the rack will be impacted by it as well. If we are going to adopt a cold plate infrastructure, then there will be the traditional racks we used to have PDUs at the back of the rack, 0U PDU vertical mounted, which connects all the servers to that. But in addition to that, there requires to be the cooling distribution manifolds at the back of the racks. And to make them redundant, you have to have two sets of those manifolds, which is going to impact your rack depth. So the racks with 1,600 by 1,000 deep rack probably will have not sufficient space to accommodate all the PDUs and all the manifolds required. So you need to be looking into more deeper rack, maybe 1,200 or millimeter or 1,300 millimeter racks. Again, it depends what equipment you are choosing. So there's more details that required to be ironed out while making these decisions. Floor loading capacity is going to increase as the densities are increasing, the loading capacity is increased, so your floor and structural capacity and your raised floor loading capacity need to be verified before putting these kind of loads. Floor plan is definitely going to change. And just an example, if you are operating a data center that has average rack density of 20 kilowatts per rack air-cooled system, which is traditionally it's the higher end of the density for a traditional air-cooled system. And now you're going to put just 100 kilowatts per rack there, which means that you need 1/4 of the space of your white space. So the rest of the space was not required because you will be running out of power and cooling in that facility. And what you do with that space, that's something you have to think about. And if you're designing a new greenfield data center, in that case, the split of gray space to white space is going to change significantly depending on your rack densities. And there will be much lesser requirement of white space and much more requirement for gray space to fit out all the upstream infrastructure, including CDUs, chillers, pumps, UPSs, power distributions, generators, and all those sort of stuff. The selection of dielectric fluid is again an important consideration, and I think we touched upon that in the previous slides. Material compatibility, one of that, but also the conductivity, viscosity, and chemical stability, cost, and environmental impacts are to be considered while doing the selection of dielectric fluid. Coolant quality and maintenance, part of the operations is, and my co-presenter here touched upon that what are the tests required to be done with the coolant quality maintenance over the period of time, and if a contamination happen, how to handle with that. So I think these are the all new things which probably the data center facilities engineers or data center IT operations are not familiar with, and they need to be retrained and upskill on these aspects. Leak detection and containment and heat exchanger CDUs. So these are some of the consideration that need to be made at the design level, at the design stage, which ensures that you're aligning with the overall organization's objectives. Commissioning of these data centers or recommissioning of repurposed facility, retrofitted or upgraded facility will be different than what we have been doing historically in data centers. So 5 level of commissioning are going to remain the same, but what is required to make it happen will change. For example, for level 4, level 5 commissioning, conventionally air-cooled load banks, as you can see on the diagram above here, were fitted into the racks or on the floor, and they take the cold air from the cry units or fan wall units and push back the hot air into the hot aisle containment or hot aisle plenum return all the way to the computer room air handling unit or fan wall units. And this is the way the UPSs are fully loaded, the generators are fully loaded, the power distribution streams are fully loaded at the same time. The cooling units and the chiller infrastructure is fully loaded, and level 4, level 5 commissioning is being completed there. Now, in the new scenario where there will be liquid cooling racks, so when we talk about the immersion cooling, about 96-97%, depends upon which kind of immersion technology you are using, 96-97% of the heat is ejected by through the liquid, through the coolant. And only 3 to 4% goes to the ambient, which requires some kind of air cooling. But when we talk about the direct liquid cooling, DLC or cold plate cooling, there's a lot of variations there. So this variation can go up to 60-40%. For example, 60% of the heat will be rejected through the liquids, but 40% of the heat is still required to be rejected through the air. Which implies that for a 100 kilowatt rack, and I'm not talking about 200 kilowatt or 500 kilowatt rack, I'm just talking about a 100 kilowatt rack, 60% means that the 60 kilowatt will be rejected through the coolant liquid side, but to 40%, which is 40 kilowatt per rack, which is immense, which is still double than the traditional air-cooled systems, is required to be rejected by the air. So you need to have a load banks that can simulate both liquid loads and the air side of the loads, and can load up whole facility and the upstream infrastructure, power and cooling, to perform level 4 and level 5 commissioning. And this is one of the challenges that a lot of data center owners are in discussion with us, who are at the advanced stage of constructing their facilities. Commissioning by project phase remains the same, but it's very important that during pre-design and design phases, when you have selected to use a specific kind of liquid cooling, then you probably need to develop overall commissioning plan, develop level 1, level 2, level 3 commissioning documents, and review your design for commissioning readiness. That's very important, that you have the proper tap-offs, where you're going to put the load banks, how you're going to connect the load banks, and what level of commissioning, what kind of rigor you want your facility to be done. Because if the facility, nobody wants to test their $40,000 GPU on an uncommissioned facility. It doesn't make sense. So that's really, really important for data center infrastructure professionals to make sure that the facility is properly commissioned before it is handed over to IT for turnover. Otherwise, the issues from the commissioning are going to pop up during the operations of IT equipment. And once commissioning is completed, the facility is handed over to operations. And now the challenge starts throughout the life cycle, or throughout the end of life of the data center. And operations teams are the one which will be handling all the decisions made at the design level and during the construction and commissioning level. So the operations team has to live with them. And most of the time, they don't have much to say when those decisions are being made, but they have to live with those decisions, and they have to make sure that the facility is being operated to the full capacity at the maximum availability once the live IT equipment is energized inside the facility. So cooling system management will change. Coolant quality and maintenance, leak detection and containment, pumps and circulation monitoring. Probably these are the kind of things that the operations teams has to be aware of, or you have to have more mechanical heavy personals in your operations team that can help to find root causes or to troubleshoot these issues in a facility, because it's not anymore power and network. It used to be power, network, and air. Now it is power, network, air, and liquid. So liquid is a major attribute here. Environment control and safety. What are the temperature and humidity requirements? Do we need more stricter control or not? How it's going to impact the liquid that you have selected? What are the do's and don'ts in that case? Safety protocol, if the liquid spills over, what to be done, where it can be drained. Different geographies and legislations have different requirements for that. So, for example, in United States, in some of the states, you cannot drain glycol water into the drain, into the regular drain of the building. So you have to contain it separately. So there have to be a separate piping system that has the tanks that can collect all that liquid, and then the vendors can take it from offsite. So that's really important. Emergency response, all these things need to be thought about. Operational efficiency and optimization. Now again, the facility and the infrastructure is built on day one, but energy management, heat rejection management, capacity planning, and scalability depends upon a lot of the set points, and the set points may keep varying as the IT hardware keep coming into the data center facility. So both for immersion liquid cooling and direct to chip cooling, this is something that the operations team has to be aware of. Historically in past, it's just the air temperature, the supply air temperature from the cooling units, and that controls everything. And then the primary and secondary chiller loop temperatures, that is, and these are the parameters which impacts the operational efficiency and optimization. But now we have another element into the data center, that is liquid cooling. So how the flow and the temperature delta T across these systems need to be managed to have the best or optimum operation from energy efficiency point of view. Maintenance and lifecycle management, data center capacity management, compliance and documentation, training and staffing. So these are the other topics, and I'm not going to touch upon in detail of each of them, but I believe it gives you a little bit of flavor that how much is going to change when the liquid cooling is going to land inside the data centers. And now there is no doubt with the data and everything, and the statistical data shows that it's going to land in your facilities. It's not a matter of if it will land, it's a matter of when it will land. So it's going to land. So you need to be, if you have plans of deploying it, then you probably should need to be thinking about training and upskilling your operations team about it. They're not only challenges with the liquid cooling, but there's also opportunities. So on the left side, we have opportunities: improved energy efficiency, enhanced cooling management, automated resource allocation, reduced human error, scalable management, operational cost reduction are the opportunities that we can look into there. But also there are some challenges, as we discussed in the previous slides, but they're listed here as well. High initial investment cost because the hardware and the infrastructure is more expensive as it's new, and I believe that it's going to drop down as there will be mass scale adoption. Complex integration and implementation, dependence on high quality data, so more data points are required. In historical data center, we just need the air temperature, air inlet temperature to the racks, and 1, 2, or 3 sensors at the front of the rack are going to give us a good picture of what the rack is happening. And if somebody wants even more comprehensive, they can look into the return air temperatures. But now different tap off, different rack inlets, different temperatures getting back from each and every rack. That's a lot more data that need to be connected. Operational risk and reliability, lack of transparency and explainability. So vendors, who are going to provide these solutions need to share transparently all the information for operation point of view with the owners and operators. Only then they will be able to get full benefit of this equipment. So some of the challenges are here. There will be more challenges as the more mass scale deployments are going to go up. One of the promising, and I think that is from last 6 months, I have not, this has gone in shadows, but before that, one of the promising feature of liquid cooling adaptation was sustainability, that lower energy is required to reject heat, which means lower PUE can be achieved. And I have discussed with NVIDIA, and they said that they can accept the liquid inlet temperature for cold plate type as high as 32 degrees Celsius, which means that economization is even possible in climates where the temperature drops up to 28 degrees Celsius. So up to 28 degrees Celsius, a delta T of 4 is reasonable for economization and heat rejection without any mechanical cooling. So that's possible to achieve that. Well, how it's being adopted and deployed in the field, it depends upon you. It depends on data center professionals how they're going to do that. But if that's the case, historically the economization starts at about 15 degrees Celsius. 15 was the benchmark for economization most of the world across most of the world. But if that's true, and the chips can a cold plate can take a higher inlet liquid temperature, the economization threshold is going to increase. Which means that even in the tropical regions, the regions where you are, there is more opportunity of economization, which is going to reduce the annualized PUE and data center carbon footprint. Now, all these challenges need to be will be solved by the humans, and the human capital, which requires training, competencies within the organization to adopt these technologies. And without the proper training and without the proper competencies, it's not possible to take full benefit of these technologies. And training is an essential element of building competencies within the organization. And training on the right technologies that your organization is adopting probably should be on the roadmap along with the adoption of technology. Some elements of training that probably I can point in this short presentation is the hardware. What kind of hardware you're going to adopt in your organization? What is the data center lifecycle management? And tier storage strategies that you're deploying. Network connectivity, as you have seen that InfiniBand and 400G Ethernet, they have their own limitations and they need to be deployed in a very specific way to get full benefit of high-end GPUs. Energy efficiency, energy management, power management, and cooling technologies all work in hand to get most benefit from these technologies. AI-driven automation. Can the AI benefit from, can the data center itself benefit from the AI in their operations? And if required, what level of automation is required in that case? Disaster recovery and business continuity. If something happens, what are the failover strategies and rapid recovery techniques? And then ethic and governance. When you're the ethical implications of AI, responsible AI practices, and also the infrastructure that you're deploying for the AI, how it will be impacting the environment around you. So these are the few things, training areas that I brought to your notice in this short presentation. And with that, I conclude my my presentation and open for any questions.
Thank you very much, Mr. Mohammed. And then we're gonna move on to the Q&A sections. So we got a few questions from the chat box. For first thing first, from Mr. Sewa. So about like the question is between direct to chips liquid cooling versus immersion with technology is more efficient in the term of implementation and maintenance cost.
Yeah, sure. You can all hear me, hopefully. Yeah. So I think Naveed also covered some of the differences between the three technologies pretty well. So considering time limitations, it's a broader discussion, but I'll keep it under like 20 seconds. So basically, you know, if you look at direct to the chip, right, in a nutshell, generally the solutions are driven by the server manufacturers, right? So if you look at immersion, it's sort of the tank is designed for the next 10-15 years of the life cycle of the data center, because you could end up immersing any immersion ready server in that tank, okay? Versus immersion cooling rack, which is designed for a server brand, for a certain version of that server brand. Okay, so and also if you look at DLC, you got all these non-redundant water loops going through the cold plates. So what we find from after our discussions with consultants, when you scale, So picture a data center of like 30, 40, 50 megawatt with hundreds and hundreds of racks, DLC racks, each rack containing so many single water loops, and what happens if there's a failure and how to maintain all that sort of stuff. So there are challenges in terms of operations and maintenance when it comes to large scale deployments. But obviously, all technologies have a use case, right? So air will continue to have a use case. DLC will have a use case. Immersion will have a use case as well. So look, I'll stop there, but happy to discuss in detail on another day because I can talk a lot on this, so I'll stop.
And the second one is for you as well. So what is the main difference between single phase and two phases immersion cooling?
So I like how Naveed covered it. Like he talked about the single phase, two phase pretty well, but I'll quickly summarize as well. And so if you look at two phase immersion, Atapan, can you remind me? It's single phase and two phase immersion, right? Not DLC. Yes, I think it was immersion.
Yes, I believe so. I think I heard the immersion. Yeah.
Correct, immersion. Okay, so to start with, we at Submer we don't do two-phase immersion because couple of things. One is the fluid used for single phase. The fluid used for two-phase immersion uses PFAS, and that's not safe for human use because you got to wear all protective equipment, and it's not safe to inhale. And also when it evaporates and it's considered as a forever chemical. So due to these sustainability reasons, we don't use and promote two-phase liquid cooling today. However, I think Naveed clearly mentioned this as well. The technology used for two-phase immersion cooling is actually good. We are convinced on the technology because it is a more efficient way to absorb the heat. However, from an environmental point of view, from a human safety point of view, we are not focusing on two-phase today. However, when we have a safer fluid exist in the world for two-phase, then we will definitely consider that technology as well. So that's the main differences between single phase and two phase from a fluid point of view. And of course, the cost of the two phase fluid is quite high, and because it evaporates, you've got to continuously top up. Whereas single phase, it doesn't evaporate. It's safe for human use, biodegradable. It's transparent, no smell. So there's lots of benefits. There's 15-year lifespan. So all those benefits are there. So we believe from a sustainable point of view that single phase sort of wins that race today.
So thank you very much. And one of the questions from Mr. Muhammad. So which standard or certificate required, especially for liquid cooling data center?
So I'm assuming the question is related to the certification of data center, which is like the design certification, facility certification of data center, and operation certifications. And if I have understood it correctly, I assumed it correctly, then the certification landscape is going to remain same. We have figured out that the liquid cooling data centers can be concurrently maintainable. They can be even fault tolerant if required. The level of investment will be different. So it's possible to achieve tier 1, tier 2, tier 3, tier 4 with liquid cooling technologies inside the data center facilities. So the design certification, facility certification, which is TCDD and TCCF, and the operation certification, which is TCOS from Uptime Institutes, are going to remain consistent. The standards is applicable to these technologies. However, these technologies has to be mindfully and correctly configured, like the power and cooling in the traditional data center, to achieve a specific level of concurrent maintenance or fault tolerant.
So thank you very much. And any more questions? You can turn up your microphone and speak out, please. If you have some more questions.
Have we put everybody to sleep on the call? I mean, that's the best thing to do during presentation. If we put everybody to sleep, and there's no questions coming after that. That is an evidence of successful session.
Exactly.
So okay, I come down to the ending part of this webinars. Thank you everyone, and Mr. Sangha and Mr. Mohammed for incredibly insightful discussion on immersion cooling and its impact on data center availability. It's clear that the technology is not just reshaping the way we approach cooling, and but also driving significant improvement in the efficiency and sustainability of the data center industry. And thank you, everyone, and for the audience for your time and attention today. We hope you found this session valuable, and that it's speaks now new ideas on how leverage immersion cooling to enhance your operations. Before we wrap up, I'd like to take a moment to highlight some exciting upcoming webinars that we have lined up. We have some more upcoming webinars in a few months, and I show you like what's on the topic. So for the first one, we got data center site assessment and health check audit. What do you need to know about your DC infrastructure? It's gonna be on April 8, 2025 from 2 p.m. to 3 p.m. GMT 7+7. These sessions will be dive into the best practice of assessing the health of the data center infrastructures, ensuring optimal performance and identifying areas of improvement. It's a must attend for everyone responsible for maintaining and upgrading data center facilities. And the second one would be AI for learning and development. Join us on May 6, 2025 as well, from 10 a.m. to 11 a.m. GMT +7. From a deep dive into the role of artificial intelligence in transforming the world of learning and development. We will explore how AI is being to personalize learning experiences and increase workforce productivity. Don't miss out. This one is quite it's quite related to the futures, and we encourage you to register for these sessions. As soon as they are open, you will find detail and registration like a link on our website or Facebook site. And on behalf of PSTC Academies, once again, thank you very much on our esteemed speakers, Asanga De Silva and Mohammed Nawi Said, for sharing your expertise today. And thank you to all you for participating. Have a wonderful day ahead, and we look forward to seeing you on our next webinars.
Thanks very much.
Thank you very
Have a
much,
nice day.
everyone.
Bye.
Have a good day. Thank you.